series on advanced separation process. Myself, Jaimin Pandya, Assistant Professor from Chemical Department of LJ Institute of Engineering and Technology. So let's start with a new chapter, which is a membrane separation processes. So in this lecture, we'll discuss about mechanism of membrane separation processes. Then we'll discuss about the membrane and classification of membrane separation processes. Then we'll discuss about various advantages and disadvantages of membrane processes. So let us discuss about mechanism of membrane separation process. As discussed in previous session, in general separation process of fluid mixture can be divided into two categories. One, equilibrium separation process, and second, rate governing separation process. Conventional separation process as a evaporation, distillation, extraction, adsorption and absorption used on large scale in industry are based on equilibrium distribution. A first phase is brought into contact with a second phase. After a certain time, thermodynamic equilibrium is established between two phases. This implies that both phases show the same temperature and all components have a same chemical potential in both phases. The analytical concentration of component in two phases, however, may differ. For example, a component can be highly enriched in phase 1 and low concentration in second phase. If now the two phases are separated by appropriate means, the enriched component can be recovered usually by the establishing a new equilibrium at different temperature or pressure. This procedure can be repeated to obtain phase in which one of the component is present at desired purity. On other hand, if separation is based on difference in transport rate through the some medium under the influence of driving force resulting from the gradient in pressure, concentration, temperature or electric field, it is termed as a rate governing separation process, and all membrane separation process are based on rate governing separation process. So let us discuss about the mechanism of membrane separation process. Membrane is one such medium separating one phase from other. Let us consider the simplified diagram of this cell membrane system as shown in this figure. The membrane is placed on rigid and high porous supported plate held between two components. The feed composed of component A and component B enter into the upper chamber and flow over the membrane. Part of feed stream is transferred through the lower chamber. With perfect membrane, only component A will be transferred through the membrane, while component B remain in upper chamber. Either component A or B may be a desired product. The agitator is used to improve mass transfer rate for the component. Now let us discuss about the membrane. What is membrane? The word membrane origin from Latin word membrana, which means skin. Membrane keep things separate in living world. They pass material selectively. The membrane can be definite essential barrier which separate two phases and restrict transport of various chemical in selective manner. In other words, a membrane is defined as a structure having a literal dimension much greater than its thickness, through which mass transfer may be occurs under variety of driving force. The membrane can be selective or contacting barrier. In the former case, it control exchange between by difference in transport rate of various component in membrane mixture. Some mechanism must be exist in membrane while facilitate transport of one component and impose the transport of other. Porous membrane discriminate according to the size of particle or molecule. Non-porous membrane discriminate according to the chemical affinity between the component and membrane material, where membrane can sharply after the rate of mass transfer. This alter the rate occurs because physical and chemical interaction between the membrane and separating component. The physical interaction include the encounter in filtration, where the different component pass through the membrane at different rate determine the size of component. So Flux of membrane that can be given by flux is equal to membrane permeability upon membrane thickness into the driving force. So membrane flux represented by this equation. This is the image of real membrane. If we are going to take cross section of this membrane, we are getting this type of image in which there is a pores and this is a top view of membrane. In from these pores, various material can pass through. A bigger molecule will reject it and a smaller molecule can pass through the membrane, and this is a scanning electrography microscopic image of membrane in which we can clearly see this pores of this surface of membrane where smaller molecule can pass through these pores and bigger molecules will reject it. So let us discuss various types of membrane processes, or can say that classification of membrane separation processes. Various types of membrane processes have been mentioned in almost all of literature. The process in which membrane are used can be classified according to the driving force used in process. So there are various driving force used in membrane separation process such as a pressure driven membrane separation process, concentration gradient driven separation process, electric potential driven membrane separation process, and temperature difference. In pressure difference, mostly consider reverse osmosis, nanofiltration, ultrafiltration, microfiltration, pervaporation, and membrane gas separation processes. Where in concentration gradient driving membrane separation process, considering dialysis and extraction processes, where in electric potential driving membrane processes, consider electrodialysis process. In temperature difference, going to consider a membrane distillation and osmotic distillation process. The principal characteristic of various commercialized membrane separation process can be specified based on the 7 aspect. First, separation goal. Second, nature of species retained, or can say that size of that species. Third one, which is a nature of species transport through the membrane. Fourth, which is a minor and major species of feed solution transported through the membrane. Fifth, driving force. Sixth, mechanism for selectivity or transport. And seventh, phase of feed and permeate stream. This table summarizes the general characteristic of various membrane processes. The more common pressure-driven membrane processes such as microfiltration, ultrafiltration, nanofiltration, and reverse osmosis is the application of hydraulic pressure to speed up the transport process. So, reverse osmosis, nanofiltration, microfiltration, and pervaporation, these all processes are considered in pressure difference or pressure driving membrane separation process, in which for reverse osmosis permeate are water and small polar solvent or salt, where in permeate of nanofiltration, which is a monovalent and ion water, there permeate in ultrafiltration, which is a small molecules and water, where permeate in microfiltration is a dissolved solute and water. So these all types of process such as a reverse osmosis, nanofiltration, microfiltration, pervaporation, gas separation, these all are considered in pressure driving separation processes. So these all processes have different types of pore size. For example, reverse osmosis have a 0.001 micrometer pore size, where for nanofiltration pore size is 0.0001 to 0.001 micrometer. For the pore size of ultrafiltration, which is a 0.001 to 0.1 micrometer. For the microfiltration, pore size is 0.1 to 10 micrometer, and for the pervaporation and gas separation, pore size in membrane is less than 1 nanometer. However, these processes are differentiated by size range of particle or solute that are separated. Reverse osmosis process is a essentially dewatering technique, where ultrafiltration is a simultaneous use for the purification, concentrating, and fractionation macromolecule. Nanofiltration is a intermediate of ultrafiltration and reverse osmosis, as the name implies that the size of solute exclude is of order of 1 nanometer. Microfiltration is a clarification process that separate molecule and particle on basis of size and solubility. It is essentially a Filtration with pores of 0.1 to 10 micron, so small that microorganism cannot pass through them. So this is all about the classification of membrane separation processes. Now let's discuss about the various advantages of membrane processes. Membrane separation process provide highly flexible separation technique for selective solute separation concentration and permeate recycling and reuse. The special feature for the membrane process that make the attractive for the industrial application are their compactness, easy of fabrication and operation and modular design. So first advantage of the membrane separation process is a appreciable energy saving. An advantage of membrane technology as compared to the conventional process is that it permits concentration and separation without the use of heat. Evaporation and freeze concentration are common dewatering technique used for the liquid product. Evaporation requires input of 1000 BTU per lb of water evaporated. Let considering if we are going to calculate this term into the kilocalorie, it's become 540 kilocalorie per kg. While freezing require 144 BTU per lb water frozen mostly to effect the change in state of water from liquid to the vapor or liquid to the solid respectively. Since membrane separation do not require change in state of solvent to effect the dewatering, this should be result in considerable saving in energy. Second advantage of membrane separation process is that clean technology with easy operation. No complication heat transfer or heat generation equipment is needed in membrane operation. This process can be operated at ambient temperature. Advantages of membrane separation process over the evaporation is no need to consider. The avoiding relative problem like the thermal pollution and sewage water, this all overcome by the membrane separation processes. Third advantage is replace the conventional process. Existing non-membrane based equilibrium driving separation process such as adsorption, absorption, then extraction, distillation, stripping may have significant disadvantage and problem or can say that difficulties such as emulsification, forming, entrainment, weeping or lack of flexibility like flooding, loading and need of density difference and other difficulties such as a slower rate, lack of modularity and need of large space. This problem can be overcome by the membrane separation process. Next advantage of membrane separation process is recovery of high value product. As a technology develop more and more situation arise where the substance of high unit value are formed in very low concentration. In conventional separation process, the separation efficiency drop rapidly as the concentration of desirable component falls. Membrane separation technique can give better answer to this all problem. Next advantage is a general flexibility in design system. With the development of new membrane with improved transport property and better chemical and thermal stability in recent years, a large number of new potential applications are identified. The membrane-based industry are responding to market need by the rapidly exploding this application on industrial scale. Next advantage which is a hybrid process development. So let us understand how the hybrid process development used in industry. In case membrane unit operation are used as a part of process design with other unit operation. This is an alternative to conventional design philosophy that would be either be membrane or other unit operation along to the completion of the process objective. For example, dehydration of organic solvent is done mostly by the distillation membrane module that can very selectively separate water from many organic liquid including alcohol. If we are going to replace whole distillation column, it might be very costlier. It is more advantage to use both distillation and membrane assembly or membrane unit combinedly in series operation. The hybrid can successfully increase the capacity of existing plant and improve product quality. A hybrid process is a successful if overall cost and performance is a improvement over the individual alternative. Now let's talk about the various disadvantage of membrane separation process. Membrane separation process suffer from certain disadvantage which lead to its application constraint. Some of the disadvantage are such as a membrane fouling, upper solid limit and expansiveness of membrane. Membrane fouling is a problem in membrane separation process. Contaminate feed increase the rate of membrane fouling, especially for the hollow fiber module. So there are mainly two types of fouling. First, which is a external fouling, and second one, which is a internal fouling. When the solute of mixture is accumulate on surface of membrane, it causes the external fouling. When the solute of mixture is accumulate in membrane surface like this, then it's cause the internal fouling. So this is all about the various disadvantages of membrane separation processes. So in this lecture, discuss about the mechanism of membrane separation processes, then discuss the what is membrane, then discuss about the various process or can say that classification of membrane separation processes, then discuss about the various advantages of membrane separation processes and various disadvantages of membrane separation processes. So this is all about today's lecture. I am completing my lecture here. Thank you.